Hi guys, welcome back to another video. In the previous video, we have been discussing about how our computer works and basic block diagram of a computer. Whenever we discuss about any electronic device or computers and anything, we normally come to a point where we discuss about the binary system. We always talk like computers and electronic devices only understand the binary number system. So today let's understand why it is so special about this binary number system. In the previous video, when we discussed about basic block diagram of a computer, we have mentioned that the CPU will understand the instructions. How CPU understand this instruction? And we also discussed like these instructions will be on binary format, and now we will be understanding why the computers and electronic device understand only binary system. When we are considering computer or any other electronics devices which all are basically powered by current and voltage, it will be like it will be supplied by AC current and it will be converted into DC by the internal circuitry, and the DC voltage and current will be utilized inside the computer, and here this voltage is logically used as binary. So the easiest two state that can be represented by a voltage is 0 and 1, because if there is a high voltage it can be considered as 1, and if there is a low voltage it can be considered as 0. So with the voltage we can create binary patterns easily. So in a binary system there is only 1 and 0. So how to represent an instruction by using just 1 or 0? So let's consider a random shop. It can be a tea shop or any cafe or anything. This is a random tea shop here and it has a light here. And the light have two options, on or off. And there is a person who is standing far away from the tea shop. So he can look into the bulb or the light and he can understand like if it is on means the shop is open, if it is off means shop is closed. So by using a single bulb, the tea shop owner can communicate two things to the customers, like if the shop is open or the shop is closed. So these two states of data he is communicating using only one bulb with the two states 1 and 0. Similarly, if he want to communicate more data, so here if the tea shop guy want to communicate more data, like he want to communicate like if there is milk available or not. If there is no milk means the who are coming now will only getting black tea. So he can communicate more data by introducing one more bulb. Now he have two bulbs. So with the two bulb he can have multiple combinations like bulb 1, bulb 2. This on, this off, off, on, off, off, on. So in the binary we can represent it as like 1 0 0 1 0 0 1 1. So basically with this two bulb he can communicate four different informations. So based on this combination he can educate his customers like if both bulbs are on, that means I have everything available in my shop and you can come and purchase anything. If I have everything off, that means I don't have anything available in my shop and my shop is closed. If I have off and on means I have milk but I don't have tea powder, that means you can only drink milk from my shop now, you will not get a tea. If I have on and off, that means I have only tea but I don't have milk, that means you have to drink only black tea from me at this moment. So this is how we can communicate by using binaries. So now consider like a case where he want to communicate more and he introduces one more bulb. So how many combination of messages he can create? So it will be like 2 raised to 3 times. So this will be the equation. If we have 4 bulbs, then it will be 2 raised to 4. If we have 8 bulbs, 2 raised to 8. Yes. So this is the list of combinations possible with number of bulbs. So if there is 2 bulbs, that means 2 into 2, there is 4 combination of messages possible by 2 bulbs. If there is 3 bulbs, that means we can have 2 into 2 into 2. That means 8 combination of messages can be communicated by using 3 combination of bulbs. Similarly, we can use 4 and 2 is to 8 means 256 combination of messages. Like by using an 8 bulb we can communicate 256 different instructions. So similarly, when we go back to our previous section or in the block diagram, so all the programs inside this memory will be of binary. So each binary lines will be representing one particular instruction for the ALU unit. So the ALU unit will be understanding each binary letters as we discussed, and whenever it is getting each specific set of binary code, it will be doing a specific task. So for further understanding, let's consider this IC. In this IC, I have 8 number of pins in one side. So if I want to give a data to this IC, I can consider giving a data like 0 0 1 1 0 0 1 0, something like this. I can give this value by giving 0 voltages in each pins. I can give 0 voltage in pin 1 and pin 2, and pin 3 I can give a high voltage, and pin 4 also I can give high voltage, pin 5 6 I can give low voltage, 7 I can give high voltage, 8 I can give 0 or low voltage. So by this I am giving an instruction to this IC. So my instruction is 00110010. 10. So IC will have a predefined logic inside this. If the data is 00110010, it has to do certain operations. So it will get this binary instruction and it will do the operation which is defined inside its system. So here I am sending the instruction and the instruction is 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8-bit instruction. 8-bit instruction I am giving. So 8-bit equal to 1 byte. So we are sending 8-bit instruction or 1 byte instruction to the IC now. So with this 8 bits, we can have multiple combinations like 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. We can create lot of these combinations with these 8-bit numbers. That means we can create that much instructions with the 8-bit input. So from this video, we got the idea about how our CPUs understand the instructions and how the instruction formed and why we use binary number system to instruct the computers and electronics devices. So in the next video, we'll look more into the number system. See you on the next video.